Good morning, students. Welcome to the online classes in physics for standard 11th. We are right now discussing about the mathematical preliminaries that we need to know before switching over to the curriculum in physics. The last class was based on the concept of slope and derivatives. In this class, we will proceed to the next step in calculus. We'll talk about integration. So there are two ways of explaining this. The first way that I would be discussing today is to discuss integration as geometrically the area under a curve. Supposing we have a function of x as y is equal to f of x. It can be any function. For example, y is equal to x, y is equal to x square, y is equal to root x, y is equal to x plus 3, and so on. So we will plot its graph. So suppose we try to plot its graph like so, this being the origin x-axis, this one, and y-axis. Now in general, suppose we get a curve like so. Suppose this is the graph of y is equal to fx. Let me make it a more general one. Suppose we have a curve like this. Okay, choose a point. We wish to find the area under this curve between 2 points, say these two, A and B. So this is the area. This shaded region we have to find. Now how do we do that? The trick lies in the fact that this region whose area we have to find, we shall divide it into very thin rectangular strips. So suppose here we have one strip like so. This is one strip starting from x is equal to a. Then we will draw next strip, next strip. This is suppose ith strip. And the location of this point, we call it as x comma y, suppose. That means this one is x and this one is x plus something. We call it as suppose x plus delta x. Area of this strip will be this, I'll call it as ith strip. This is ith strip. So this is the first strip, and we'll have second, third, fourth, and so on. This is ith strip, and the last strip will be over here. This one. This we will call as nth strip. Suppose n number of strips we are drawing. Now what we would do, we would find the area of each strip one by one, and then we will add the areas of the different strips to find approximately the area under this curve. So area of this ith strip will be, see, here if I make a rectangle, there will be a portion which will be left. That portion, let me mark here, shade it. This almost a triangular portion will be left. This one. Apart from that, the remaining portion, this will be a rectangle. So area of this rectangle will be length into breadth. Now this height you can see is nothing but y. And this thickness is x plus delta x minus x, that is delta x, and plus a small region like so. This small area is also to be included. Now that gives the area of this particular strip. This this strip at its top, a triangular element which is left behind, it has a small area but not zero. So we cannot neglect it right here. Likewise, we will find strip adjacent to this one, then next one, then next one, and we shall find the area for each of these strips, and we will go on adding them. After adding all the areas of all the strips, we should get the area under the curve. All these strips at the top, a triangular portion will be left like so. This one will be extra from the rectangular portion, and so on. So these extra portions on adding may become a significant number. So the total area under the curve from x is equal to a to x is equal to b is obtained by summation of this. So we can write it as summation of y. Now y is nothing but fx. So I can write instead of y, f of x. Then we have delta x and plus this value. Now this value I am not writing an expression, just I am indicating it by a small triangular portion like so. There is no harm in indicating like this. So this is for one strip and this symbol is a summation. So for all the strips we have to add this. We will get the total area under the curve. Okay. Now this particular element which is left behind at the top of each strip, it is creating some problem. So we want to minimize this error. So to minimize this portion, this area, what we can do, we can make the strip thinner and thinner. If we omit this part, so this is exact value. Now if we write this summation like so, fx delta x, neglecting this part compared to this part. See, this is the significant portion of the area, the rectangular part. This triangular part is very small. It is not zero but small. If somebody writes this area as this one, this is not accurate. It has some error. So this we say it is not accurate. It will give you a rough idea about the total area under the curve, but it will not be accurate. To be more and more correct, this should be minimized. So there is some error. If you write area as this much, there is some error. That error is because of this particular part. So to minimize the error, what we need to do, the strips should be made thinner and thinner. If we make these strips thin, so like so, then for this strip and for this strip you add the areas of the rectangular portion. So those is this part, the triangular parts above the rectangular portion, they will get minimized. If you go on doing this, when you make the strips thinner and thinner, the number of strips n we say tends to infinity. Infinite number of strips we have to draw, and the breadth or the thickness of each such strip will become very very less, almost approaching to zero. So that, so in the limiting case, as n tends to infinity, what is n? N is the number of strips. If we make infinite number of strips from x is equal to a to x is equal to b, then delta x tends to 0. What is delta x? Delta x was this thickness of a strip. This is x plus delta x. So delta x is the thickness of that strip. So thickness of the strip tends to 0, and the summation symbol, it tends to, we say, integration. Meaning is same, summation. So this summation we will replace by integration. Its symbol is some sort of s, stretched s. Then we have fx, so we write fx. Then we had delta x. Now let me first write it in this form only. Earlier, this is summation, we had I is equal to 1 to n. You can write f of xi delta xi. So there were n strips. Now here we have limiting case when delta x tends to 0. You can also understand that number of strips tends to infinity. Under this limiting case, this summation will become integration. Fx remains as such, and you know students, if delta x tends to 0, we write it as dx. I have introduced this concept of dx and dy in case of derivatives. So since delta x tends to 0, this we will write as dx. See, basically the difference between this expression and this expression is not much. If you are able to understand this, you can extend this idea to this. What is the difference? Here, this is a finite number of integral intervals, their sum of their areas. Suppose we have 100 strips. Each strip we are finding the area and then we are summing them. We are adding them. Now, if instead of 100, if we increase this number to 1000, then to 10,000, then to 1 crore, then each one of those strips will go on becoming thinner and thinner and thinner. In the limiting case, when we make a large number, when I say large number, make it infinity. When we make infinite number of rectangular strips, then delta x will tend to 0, that is thickness of each strip will become 0, number of strips become infinity, summation will be replaced by integration, and this becomes accurate answer. The error will be 0. Error in what? Error in computing area. Why error will be 0? Because when you make these strips very very fine, each strip will look almost like a line, almost like a line. So the triangular part which we were discussing earlier, that triangular part will be missing. So those areas will be almost equal to 0 in the limiting case when we have n tends to infinity. This expression we call as integral fx dx. So fx into dx, basically it is nothing but area. Clear? So let me write the geometrical interpretation. So in the limiting case, we have x, we have y, we have this curve. This is a, this is b. So integration fx dx from x is equal to a to x is equal to b. Here also I should have written this, is nothing but area under the curve, which curve? Y is equal to fx, from x is equal to a to x is equal to b. This is the geometrical interpretation for integration of a function. Now, having understood this, let me remind you derivative when we discussed. There I had discussed that dy by dx, derivative of y with respect to x, it is a slope of tangent to the curve y is equal to fx. And this we have defined as limiting value of delta y by delta x when delta x tends to 0. So this is geometrically slope of tangent, and this is geometric integration is geometrically area under the curve. So one is the slope, one is other one is the area. So I hope this concept of integration as area under the curve is clear to you. Now to proceed further, we want to discuss these things that we would need in solving numericals in physics. There is another way in which this concept of integration is introduced. Mathematically, we say integration is the inverse operation of differentiation. Now let me put it uh, mathematically with the help of some examples. Now before I discuss it, let me write two things. One is integral, suppose fx dx, other one is integral fx dx from a to b. This we call as indefinite integral. This is indefinite integral. And the second one is definite. Because in the second expression, we have indicated the limits. So we have to find the area under the curve y is equal to fx from x is equal to a to x is equal to b. Those limits are not given here, so we are not sure about which area to be considered. So that's why this is referred to as indefinite and the bottom one as definite integral. Now let us see this. Inverse operation of derivative is integration. For example, you know d by dx of sine x is cos x. Derivative of sine x is cos x. That means if you integrate cos x, you will get back sine x. And how do we write that? Integration of this you should multiply here dx into cos x. So cos x times dx will be how much? Sine x. So please acquaint yourself with the symbols. D by dx, derivative of sine x with respect to x. That is the way you have to read it. So d by dx of sine x is equal to cos x, or derivative of sine x with respect to x is cos x. Integration of cos x will be sine x. This dx you have to write there. Integration cos x dx is equal to sine x. Likewise, if you write suppose d by dx of cos x as minus sine x, then integration of minus sine x dx will be how much? Cos x. Now this minus sign you can take it this side. Likewise, we can write many examples. So you need not memorize them. If you remember the derivatives, you know the integrals for these functions. So here we will have integration of minus cosec square x dx is equal to cot x. Now this minus sign I can take it to the right hand side. Now here I can do one more thing. Let me write instead of sin x plus some constant c. So you know derivative of sin x plus c can be written as d by dx of sin x plus d by dx of c. D by dx of sin x will be cos x, d by dx of constant will be 0. So the answer will be cos x. So sin x derivative is cos x, sin x plus some constant, its derivative is also cos x. Because of this reason, when you write integral cos x dx, you can write sin x, you can also write sin x plus some arbitrary constant c. So I will put this c everywhere, where c is some arbitrary constant. Okay. Likewise, we have derivative of sec x. So this will be sec x tan x. So integration of sec x tan x dx is equal to sec x plus, we write c. Then cosec x, its derivative is minus cosec x into cot x. So this implies integration of this term minus cosec x cot x dx will be cosec x plus c. Now this minus sign you can put that side, so we will get this much. Now let's see this one, d by dx of x to the power n. This we have read as n times x to the power n minus 1. Using this, you can write d by dx of x to the power n plus 1 if you wish. This will be n plus 1, the power is n plus 1, into x to the power minus 1. So power is n plus 1 and minus 1. So 1 will cancel. So derivative of d by dx of x to the power n plus 1 is equal to n plus 1. Now n plus 1 is a number. This number we can put here also. We'll divide it this side. So this will be outside the derivative, but because it is a constant, it can be taken inside also. Now what will be left? X to the power n. 1 will cancel. So derivative of this function is x to the power n. So its inverse process, integration of x to the power n dx is equal to x to the power n plus 1 by n plus 1. And for indefinite integrals, I have told you can put plus c. Now we know derivative of e to the power x is e to the power x. This implies integration of e to the power x dx is also e to the power x plus c you can put. So you must remember these relations. One more I'll put here. Derivative of log x is 1 by x. So this implies integration of 1 by x dx is equal to log x. Okay. Let me use this particular formula to just I'll discuss one particular example. Integration x to the power n dx is x to the power n plus 1 by n plus 1. So this is indefinite integral. We will discuss how to find the value of definite integral. Let's see. Suppose so let me write it again, d by dx of x to the integration of x to the power n dx is how much? X to the power n plus 1 by n plus 1. Suppose I wish to find integration of x dx from 0 to 2. Now x, what is the power here? 1. So n is equal to 1. This will be how much? X to the power n plus 1. So here I'll write 1 plus 1 by 1 plus 1. See, it's not necessary to put this c here. I'll explain you why. Or let me write plus c, no problem. So this becomes how much? X square, and here 1 plus 1, 2. So x square by 2 plus c. Now the limits are from 0 to 2. This is the initial value, this is the final value. We will first put final value, then we'll put initial value, and then we'll subtract them. So this is the initial one, this is the final one, the square bracket we used to put. That is the way it's written. First put 2. The x is equal to 2. So it becomes 2 square by 2 plus c. Then put x is equal to 0. So 0 square by 2 will be 0 plus c. Now I was saying no need to write this c, because when you find definite integrals, when you find this difference, this is c and this c, whatever be the value of c has to cancel. And that's why we often omit this c and we don't write. So 2 square by 2 is how much? 2 units. Okay. Let us try to find the same thing geometrically. First we plot the graph, x-axis, y-axis. What is our function? Our function is y is equal to fx, where fx is given as x. Y equals to x. That means if x is 0, y is 0, x is 1, y is 1, x is minus 1, y is minus 1. You know how to plot the graphs. So 0, 0, then 1 and 1, then 2 and 2. You will get a straight line. Now if this is 1, this will also be 1. If this is 2, this point will also be 2. So you can easily find it out that this angle turns out to be 45 degrees. Okay. Now what you have to find? We have to find integration 0 to 2 x dx. So what does geometric interpretation of integration convey us? So this is nothing but area under the curve. From where to where? X is equal to 0 to x is equal to 2. Where is x is equal to 0? Here. X is equal to 2 here. So we have to find this area. What is this shape? Triangle. Half into base into height. How much is base? 2. How much is height? This is the height. It is also 2. So this becomes half times 2 times 2. So 2 cancels, 2 square units. And what we had got earlier? 2. This is the concept of integration. So here we have obtained this value geometrically. Here we have obtained as per the formula of integration. Now in this particular question, you might feel that it's better to do it this way, but not always. Suppose instead of y is equal to x dx, instead of integration x dx, suppose I give you integration x square dx from 0 to say 3. Then if you try to plot it geometrically, y is equal to fx, and that fx is how much? X square. X square graph will be something like this. This shape we call it as parabola, about which in details you will read in mathematics. So it will be curve. So suppose this is 0, this is 1, then we'll have 2 and so on. Let me write 0 to 1 and so on. Now this, if you are willing to find integration x square dx from 0 to 1, so this is 1. So under the curve, so below the curve and above the x-axis, this area you have to find. Now here this shape was a familiar shape to you. You know that the formula for area of a triangle is half times base times height. But you don't know any such formula for finding area of this shape. So, but of course, this area, if you can derive some formula, if you can find this particular area, that is the answer to this question. So it will be difficult. So here we would use this particular relation only. So we will use this formula. Integration x to the power n dx is x to the power n plus 1 by n plus 1 plus c. So integration x square dx 0 to 1. Now I told you earlier, no need to write c because c will cancel. So let us see. What is the power? 2. So we have to add 1 to 2. So x to the power 2 plus 1 by 2 plus 1. So this will become x to the power 2 plus 1 by 2 plus 1. And the limits of integration are from 0 to 1. So this becomes x to the power 3 by 3. Limits from 0 to 1. So put x is equal to 1. So 1 cube. 1 cube is 1. So 1 by 3 minus x is equal to 0. So 0 cube by 3 is 0. So the answer will be 1 by 3 units, square units. Okay. So this is the method for finding area under a curve. I would like you to remember these two relations, students, which are very simple. The most basic ones, they will be used again and again. So derivative of x to the power n is n times x to the power n minus 1, which we have discussed in the previous class. And today we discussed integration x to the power n dx is x to the power n plus 1 by n plus 1 plus some constant. Derivative means slope, integration means area under the curve. Okay. Now in the context of physics, last class students I discussed that instantaneous velocity v is given as time rate of derivative of position, so d by dt of x. So derivative of position with respect to time is speed, velocity. Now let me use this. I have discussed x to the power 1 dx, x to the power 2 dx. If we have integration dx, this can be written as x to the power 0 dx, because here we have a 1. So 1 can be written as x to the power 0. So as per the formula, this becomes 0 plus 1, and here also 0 plus 1. That is nothing but x. So remember, integral dx is nothing but x. V is dx by dt. This implies I can write dx is v times dt. Then I'll integrate it on both sides. So integration dx is equal to integration of v dt. Then we should put the limits. Now we choose the variable. Here you see dt and here we have dx. So here t should be taken as the variable. Here x should be taken as the variable. Time generally we take it to start from 0 and to sometimes say t. When time was 0, the position of dx, I can write it as suppose x naught. So I can call x naught as initial position. And at time t, the position changes to x. Let me make you understand this these symbols. We had v is equal to dx by dt. Dx is a very small displacement in time dt. Very, very small. How small? Almost tending to 0. So dx we can write as v dt. So dx is a very, very small displacement covered in a very small time dt. So if we increase the time, the dx will also change. So here the limits of integration, then we integrate. Integrate means summation. Dx, 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 all those dx you have to add. So integral dx is equal to integration v dt. Here the variable is t. Here the variable is x. T changes from 0 to t and x changes from x naught to x. X naught is the position at t is equal to 0 and x is the position at t is equal to t. Now integral dx I have told you students that is how much? X. So this becomes simply x with the limits from x naught to x. Now if you are given the expression of a velocity, suppose velocity varies with time as 2t square plus something 3, then you will put that value of v and then you can calculate this integration and you can solve for x. So this becomes integration v dt 0 to t. Now this we have discussed earlier. X is equal to x we will put first, then we will put x is equal to x naught. So this becomes x minus x naught is equal to v dt integration from 0 to t. Is it clear, students? Next, likewise, we shall see number 2, relation between instantaneous acceleration and velocity. So the instantaneous acceleration, we define it as rate of change of velocity with respect to time. So we write a as dv by dt. So if v is given as a function of time, we can find acceleration using this particular formula. Now from this we can write dv is equal to a times dt. Then we will integrate both sides. Time, the limits will take from 0 to t. Here the variable is dv. So speed initial to final. We will take the limits. So v naught is the velocity at time t is equal to 0 and v is the velocity at time t is equal to t. So v naught is initial velocity, v is the final velocity. If acceleration is given, then you can find this particular expression for velocity. Integration dv will become v and the limits will be from v naught to v. This becomes v minus v naught and that RHS we have same thing, that is integration a dt from 0 to t. Okay, so this is the main formula and its inverse, this one. If you know x, you have to find v, we will use this formula. If you know v, you have to find x, we will use this formula. And that's why we call integration and derivatives as the inverse process of one another. If you know velocity and you have to find acceleration, you will find the derivative. If you are knowing the value of acceleration, expression for acceleration, and you have to find expression for velocity, then we have to use this particular relation. Okay. So I would end up by discussing one simple example. But before I discuss this example, let me tell you that if in an integration we have two functions, their sum, integration fx plus dx, then this becomes separately we integrate them both. So integration of fx dx plus integration of gx dx. The same rule holds true for negative. Integration fx minus gx dx will be integration fx dx minus integration gx dx. So let us discuss one simple example in the context of physics. The acceleration of a particle moving in one dimensional path. One dimensional means along a straight line path is or varies with time as acceleration at an instant t is equal to 3t plus 2 in SI system. So we are choosing SI units. Okay. So this is the expression for acceleration. Number one, we have to find its velocity at t is equal to 2 seconds if it is given that its velocity was 0 or if it starts from rest. It is given that the particle starts from rest, so we have to find its velocity at t is equal to 2 seconds. Okay. Then another question in this, find the position of particle at t is equal to 2 seconds if initially it was, initially when I say, I mean initially means t is equal to 0 in the beginning. Initially the particle was at x is equal to 1 meter. Okay. We are using SI system, so we will write x is equal to 1 meter. So when I say initially, that means this is the value of x naught. Okay. So solution. First of all, the acceleration, whatever it is given, we'll write it. Acceleration as a function of time, it is given as 3t plus 2. Okay. Now we have to find what? Velocity. So we know that acceleration is dv by dt. So this implies I write dv is equal to a times dt, and then we shall integrate it as I have discussed earlier. Now the time here dt, time is the variable. Time will start from 0 and it ends at 2 seconds. Velocity initially, when time was 0, it is given in the question that the object starts from rest. So when the time was 0, velocity of the object was also 0. When time was 2, velocity is not known. Suppose it is v. So we have to find the value of v. Okay. So let's see. So this implies what is integration dv? I have discussed integration dx is x. Likewise, integration dv will be v, and the limits will be from 0 to v is equal to what is the value of a? A you put the value 3t plus 2, 3t plus 2 whole into dt, and then we have to integrate it from 0 to 2. Let us see how to find this particular integration. To integrate this, what we will do, we will segregate these two terms. So I will write it as 3t dt plus 2 dt. Okay. Now 3 and 2 are constants, so I can take them out of the integration. So 2 will come out. And the limits are from 0 to 2 is equal to 3 times. What is integration of t dt? See, we have discussed integration of x dx is x to the power 1 plus 1 by 1 plus 1. Instead of x, we have t. So integration of t dt will be t to the power 1 plus 1 by 1 plus 1. That is t square upon 2. And the limits are from 0 to 2. Plus integration dt is nothing but t, and the limits from 0 to 2. And in the left hand side we have v. First we will put v is equal to v, then we will put v is equal to 0, and we will subtract. So this implies v is equal to this. Now simplification is to be done. So let's see what we get. This implies we write v is equal to, this 2 is also constant, we can take it out. So 3 by 2. Now t square. First we will put t is equal to 2, then put t is equal to 0, and then we shall subtract. So 2 square minus 0 square plus next term 2 into, here we have t from 0 to 2. So first we will put final value 2, then we shall put initial value 0, and we shall subtract. So 2 minus 0. So this becomes 3 by 2 into 4 plus 4. So 4 you can take common. 1 plus 3 by 2. 1 plus 3 by 2 is 5 by 2. So this becomes 10 meters per second. So this is the answer. The velocity of the particle will be 10 meters per second at the end of 2 seconds. That is the answer to our first question. Now, if you see the second part, in second part we have to find position. So to know position, we need to know what is the expression for velocity. Now, expression for velocity is over here. We'll not do it the definite part. So let us see. I'll rub this part. For number b, first we have to find velocity, expression for velocity. Okay. Now it is given. We know that a is equal to dv by dt. So this implies dv is equal to a times dt. We integrate it. When time is 0, velocity is also 0. When time is t, velocity will be v. General expression we will find first. Okay. So put the value of a. A is given how much? 3t plus 2. So instead of a, I will put 3t plus 2 times dt. As we have done earlier, we shall separate it. So I'll do it directly. So integration dv will be v. Limits will be from 0 to v. And this will be 3. I will take it out. I'm writing it directly because I have solved it earlier. Integration of t dt will be t square by 2 plus 2 is constant, it will come out. Integration dt will be t. The only difference, earlier we had taken the limits from 0 to 2, now we'll take the limits from 0 to t. So this becomes 3 by 2 into t square minus 0 square plus 2 into t minus 0. So this becomes 3 by 2t square plus 2t. Okay, so this becomes v minus 0, that is v. So this is the expression for velocity. This was important to be found. Now from this velocity, what you have to find? Position of the particle at t is equal to 2 seconds, and it is given that initially x naught is 1 meter. When we start counting the time at t is equal to 0, the position is how much? 1 meter. Okay. So I am rubbing this part. Just as we obtained velocity from acceleration, likewise we can obtain position from velocity. See, velocity is given as dx upon dt. So this implies dx will be v times dt. So we can integrate both sides. Here the variable is time. Time will be from 0 to t. And here the variable is x. X will be from initial value to final value. What is initial value of x? It is given in the question 1. And the final value will be how much? That is what we have to find. So the limits of integration will be from 1 to x. Okay. What is integration dx? X from 1 to x. What is the value of v? Put this value 3 by 2t square plus 2t. 3 by 2t square plus 2t. This is the value of v. Multiply by dt and take the integration from 0 to now t. What is t? Our t is 2 seconds. Here we will take the limit to be 2. So x is 1 at t is equal to 0 initially, and x is to be calculated at time t is equal to 2 seconds. That is what we have to find. So this becomes, first put x is equal to x, then put x is equal to 1, and then subtract is equal to. I will segregate these two terms. We will solve them separately. First one is 3 by 2 constant, we'll take it out, integration t square dt. Second term will be 2 constant, we'll take it out, t dt, and the limits from 0 to 2. 0 to 2. So this implies x minus 1 is equal to 3 by 2. What is integration of t square dt? Power is 2. So t to the power 2 plus 1 by 2 plus 1, that is t cube upon 3. Limits from 0 to 2 plus. What is integration of t dt? Here the power is 1. So t to the power 1 plus 1 by 1 plus 1, that is t square by 2 from 0 to 2. Then let us compute it further. So this implies x minus 1 is equal to 3 by 2. See, this 3 and this 3 will cancel. So we will be left with half. Then t cube from 0 to 2. So it becomes 2 cube minus 0 cube. Plus, again this 2 and this 2 will cancel. So t square from 0 to 2. So first 2 square, then 0 square, then we shall subtract. So is equal to half into 8, that is 4, and this is 4, that is 8. X minus 1 is 8, so x is 9 meters, because we have discussed that we are using the SI system. So I just wanted to invoke the concept of integration for solving a very simple problem in physics. Now this might appear very new to you, but give some time. Please do not be in a hurry. Step by step, try to understand each and every point which I tried to discuss in today's class as well as in the previous class. These two classes form the basis for entire mechanics. In principle, we are done with mechanics. Chapter 1, Chapter 2, Chapter 3, a bit of a vector knowledge is needed. If you have good understanding of vector with this much knowledge, if you are sufficiently good in mathematics, you will be able to solve all the questions. So I again request you to please go through the last class content and this class content on derivatives and integration properly. And in the next class, I'll come up with some core physics problems that can be discussed based on this. So till then, take care, students, read well, and may God bless you. Thank you.